the drug concentration in the bloodstream T hours after the injection is given approximately by this formula, which is C of T is equal to 4.35 e to the power minus t, and this formula is valid when t is between 0 to 5. And here it says that C of T is actually the concentration, and which is in milligrams per milliliter. Okay, so that is the information we have given. So we have given the drug concentration, right, in the bloodstream T hours after the injection is given by that formula. Okay, but what is the question here? Our question begins here. What is the rate of change? So our goal is to find the rate of change, but of what? Rate of change of the concentration. How do you find the rate of change of concentration? Rate of change can be always figured out by finding the derivative. So if we are figuring out the rate of change of the concentration, then we need to find the derivative of the concentration, which is C of t, right? So it looks like then we need to find the C prime of t. But when? It says that after 1 hour. So that means we need to figure out what is C prime of 1. So this is the information we extract by reading this line over here, right? So we have given C of t is equal to 4.35 times e to the power minus t as a formula, which will give you the concentration in the bloodstream T hours after the injection. And if our goal is to find the rate of change of the concentration after 1 hour, then our problem is to find what is C prime of 1. Okay, so this is the question. So we just formulate this given information. So let's try to just spend time on here. So how to find C prime of 1, okay? So how can we do that? How can we find C prime of 1? Well, to find the C prime of 1, first we need to know what is C prime of t. We need to find the derivative of the function, right? That will give you the rate of change of the concentration. That's what we needed to figure out. Alright, so if that is the case, let's find the C prime of t, which is the derivative of the given function 4.35 times e to the power minus t with respect to t. Right, so this is what we need to figure out. How can we find this derivative? We can use the constant multiple rule, which is 4.35, take that out and just find the derivative of e to the power minus t, right, by the constant multiple rule. All right, so 4.35 is as it is, but what is the derivative of e to the power minus t? We know that the derivative of e to the power t is just e to the power t, right? So but here we have the exponential function composed with minus t, so we need to use the chain rule. So how do we apply that? We first need to know what is the derivative of e to the power t, which is e to the power t, but instead of that, since we have minus t function composed, so we replace that t by negative t, right? And now don't forget, because we have the composite function here, so we need to multiply by the derivative of the negative t, right? That's what the chain rule says. So just multiply by the derivative of the minus t. Alright, so this is then equal to 4.35 e to the power minus t. What is the derivative of the negative t with respect to t? Negative t means negative 1 times t, right? So in that case, negative 1 multiplied by derivative of t with respect to t, which is 1. On that case, the derivative of the minus t is just negative 1. So negative 4.35 e to the power minus t is the derivative of the C of t, right, or the concentration function. So if that is the case, now let's try to go ahead and then, because our goal is to find what is C prime of 1, right? So to find the C prime of 1, then let's try to evaluate this C prime function at 1. So let's just replace t on this function over here by 1. All right, so let's do that over here. So this is then equal to negative 4.35 times e to the power, we need to replace that t by 1, so we'll just get that is equal to negative 1, and that is the rate of change of the concentration after 1 hour. But if you want to write down that in terms of the number, let's just use your calculator. First compute what is e to the power minus 1 and multiply by negative 4 times, so negative 4.35, or everything, put it in your calculator and then get the approximation, which is actually negative 1.60, right? So this is the rate of change of the concentration we figure out after 1 hour, right? But what does it mean by this? Actually, it means that after 1 hour, the concentration is decreasing at the rate of 1.60 milligram milliliter per milliliter, right? So per hour. So that's what it means.